Okay, so we've defined function composition in that last video, and now what we want to do is actually try and find some of these compositions with an example. So I have here a function f of x is x squared, g of x is square root of x plus 1. We want to find g of f of x and f of g of x, and we're also asked to give their domains. So for a problem like this, it's helpful again just to find the domains of f and g. Okay? So let's see, what's the domain for f of x? Well, let's see here. We don't have any division. We don't have any square roots, so we can say that it is all real numbers, or negative infinity to positive infinity in interval notation. And how about the domain for g of x? Well, we know once again that x plus 1 has to be greater than or equal to 0, because whatever is inside the square root cannot be negative. So x has to be greater than or equal to -1, or in interval notation, we can use the square bracket here because it's greater than or equal to, going from -1 to positive infinity. Okay? And it's important to keep this in mind because if you recall from the other examples, whatever comes out of these compositions, their domain has to be equally restrictive or more restrictive than f of x and g of x. Okay? So let's first find g of f of x. And so what this really means is I just write g, I'm going to write part A here, my solution. Okay? I'm going to write g, parentheses, and I'm going to put whatever is f of x into this expression. So I'm going to put x squared in here. Okay? And I'm going to copy my g of x function, the square root, but instead of writing x, I'm going to write whatever is in this parentheses. Okay? So in this case, I'm going to write x squared. So I take f of x, which is x squared, and I replace the x in g of x. And then let's just simplify this. This is equal to the square root, and this just gives me x squared plus 1. Okay? So it's got to be square root of x squared plus 1. Okay. And now I want to find the domain. So again, because I have the square root, whatever is inside it has to be greater than or equal to 0. Subtract 1 from both sides. Okay. I know that x squared can be any number that is greater than or equal to 1. Oh, I'm sorry, greater than or equal to -1. Okay? And since I have the x squared here, whatever value I put in for x, it's always going to give me a positive number. So I really don't have to worry about this. X can be any values. Okay, so x can be all real numbers, okay, because no matter what I put in here for x, it's going to be positive, and any positive number is going to be greater than or equal to -1. Okay? So it would seem that our domain here is all real numbers, but we have to go back and look at the original functions. We have to go back and look at g of x and f of x. Okay? And again, we have to use the domain that's the most restrictive. We can't just make it all real numbers when it was originally from -1 to positive infinity. Okay? So even though in this function x can be all real numbers, in the original function, and I'm going to say here, since g of x has a domain from -1 to positive infinity, okay, and it's more restrictive than this, then g of f of x also has domain from -1 to positive infinity. Okay, now we're going to finish our second example here by finding f of g of x. So this time I take f of x, and that's x squared, and I take the expression for g of x, and I put it in here where x used to be. So I'm going to take the square root of x plus 1. Okay. Now we can actually continue a little bit further algebraically and see how the square root and the square cancel each other. And normally that's what we would do, but again in this case with function compositions, we're going to leave it right here because of the domain. So let's find the domain of this. Okay. If we were to square this, we would get x plus 1. Okay, I'll write a note here. If we would actually square it, we would get x plus 1, and the domain would be all real numbers. Okay? However, if you look at the original domains of f of x and g of x, the most restrictive one we have is the domain of -1 to positive infinity. Okay? And that's what we have to go with. We have to go with whatever is the most restrictive domain, because all of the numbers less than -1 aren't even a part of g of x. Okay, so we're going to have to leave it as this expression as it is, okay, and we have to say that the domain is going from -1 to positive infinity. Okay? And so let's illustrate this with a graph. So I'm going to take my calculator and type in the parentheses, the square root of x plus 1, and then square everything and graph. Okay. And you can see from the graph, and I'm going to even zoom in a little bit here. You can see from the graph that it doesn't start until, it only starts at -1. So if I hit trace -1, that's going to give me an answer. Okay. But if I go any further to the left, like -1.001, that's going to give me an undefined answer. And that's because this is the domain. And this is very different than if you were to graph x plus 1. That's going to be all real numbers. But because of the function composition, we have to go with the most restrictive domain. And that's what this is.